All right, I think hopefully we're going to finally finish section 3-4 after 4 days of this section. All right, so I'm hoping we do. We should. This is pretty short. It's not too long. Let's do it. So parallel lines, you know what parallel lines are, correct? Parallel lines are lines that what? They never intersect. That's it. Okay, they're in the same plane. Technically, you have to say they're lines that are in the same plane, because we talked about lines that are in different planes that don't intersect. We don't talk about it often. Like one time we talked about it. It's a weird word. Anybody remember that word? It was on a quiz, I think. Maybe. Was it on a quiz? I don't know. You had it on a couple of homework problems. Two lines that don't intersect, but they're not in the same plane. What do you call those? Anybody remember? Starts with an S. It's a weird word. No, that's not a weird word. Supplementary is not a weird word. SK. I gave you half of it right there. What is it? Skew lines, right. Skew lines. Remember that? It's a funny word. So they are also lines that don't intersect, but what did I say about that? They're not on the same plane. But these are on the same plane, okay? So lines that are on the same plane are called parallel. Now, there's something about the slopes. That's what we're dealing with in this lesson. We want to talk about the slopes of lines that are parallel. So if I was going to walk up this mountain right here, here's me. Does that look like me? I got my backpack. There's my backpack. All right. And there's my hiking poles. I use hiking poles when I hike. There's my hiking pole right there. Okay. And I'm walking up this hill. All right. Now, if somebody else is over here walking up this hill, tell me something about how steep both of those hills are. It's the same steepness, okay? So that must mean they have the same what? Slope. That's right. So parallel lines have what? The same slope, okay? Now, they might intersect, or they might have a different y-intercept. We haven't really talked about that in here, have we? Okay, but, well, let's just do one real quick here. Let's do, oops, not what I wanted. Let's do this. I wasn't going to do this, but I got time. So let's have them slant a little differently. Oops. All right. Now look at those two red lines right there. They have the same slope. They're just as steep. One's just a little higher than the other one. Does that mean it's any more steeper? Okay. Is it any steeper being up here? My goodness. Middle of class doing stuff like that. It would have been easier calling the people that don't have to go to the office. That would have been I think it'd be less people on the list. All right, so anyway, here we go. So look at this. This has a y-intercept right here. You guys did that. Did you guys do that in Algebra 1? Yeah. So that has a y-intercept here, has a y-intercept right here. So they cross the y-axis in different spots. They cross the x-axis. They also have x-intercepts. Did you know that? Probably didn't talk about x-intercepts very much. Usually just talk about y-intercepts. But that's an x-intercept, that's an x-intercept. So they have different x and y-intercepts, but what is the same about both of these lines? How steep it is, which means they have the same what? Slope. Jaden, did you have a point? No? Okay. All right, everybody got it? So when you have parallel lines, I'll keep this in red, I guess. When I have parallel lines, they have equal or the same slopes. I'm going to write it like this. No. Give me 5 minutes. Watch. If I got the slope of one line, if they're parallel, okay, if they're parallel, the slope of one line is parallel to the slope of another line. Oh, what did I just do? I was thinking parallel. I put this parallel. The slopes are what to each other? I should have said equal. So sorry about that. Erase that little parallel line thing. All right, so if their lines are parallel, then slopes are equal to each other. Let's talk about this. What was the other part of this lesson? Perpendicular. What does perpendicular mean? They're what? Well, they do intersect, that's true, but that's not true about every, look, are they perpendicular? They intersect. No? Jaden? Make a 90-degree angle. They make a right angle to each other, okay? Everybody see that? Now, it doesn't have to stop right here. It seems like I always stop that right there. It doesn't have to. It could keep going like this, right? And these are lines, right? So that could keep going this way, could keep going this way, right? So if you have a right angle right here, that means that they are what? What's the word? Perpendicular. Let's write that down. Let's spell it correctly too, okay? It's perpendicular. Perpendicular. Okay? What if I do this to the line? Let's move this over because I know I'm going to grab it once I do what I'm going to do. There we go. What if I did this? Oops. Almost had it. Almost. Here we go. There we go. What if I did that? Are they still perpendicular? Sure. Okay, I just twisted the whole thing a little bit. All right, it's just not vertical and horizontal now, the two lines. Okay, they slant a little bit. They're still perpendicular. Okay? Now, I'm not going to give you a big, great explanation of why this next thing is true. I'm just going to show you. So we'll call this, I don't know. This is not usually how you would name a line or label a line, but I'll just call this line 1 and line 2. Is that all right? All right. So let's take a look at the slopes. First of all, this slope right here, this line 2, is it a positive or a negative, or is it no slope, or is it zero slope? What kind of slope is line 2? Say it. It's positive. Very good. What about slope? The slope of line 1? It's negative. Everybody see that? All right. So when lines are perpendicular, it doesn't matter how I twisted that thing. When I have two lines that are perpendicular to each other, one line is going to be positive and the other is going to be negative, okay? So that's one thing. There's two things that we know about perpendicular lines. That's the one thing, okay? The signs are opposite each other, or they're inverses of each other, if you want to call it that, okay? Everybody with me so far? Yeah. Now, look at line 2. Would you rather walk up line 1 this way, or would you rather walk up line 2? When I say would you rather, meaning what would be the easiest walk? Would it be going up line 1 or would it be going up line 2? Line 2, because it's not as steep. Would you agree? Yeah. So they don't have the same steepness. Line 1 is way steeper than line 2. In fact, how can I say this? It's inversely as steep, okay? Which means if the slope of this line, let's say the slope of line 2 was, I don't know, let's say it's positive, right? Let's say it's like, it's just 2 over 1. Everybody with me on that? Then the slope of line 1 is the inverse or the reciprocal, right, of line 2. So this is a positive 2. This is going down, so it's negative. So the slope of line 1 is going to be negative, and then it's the inverse of 2 over 1. What's the inverse of 2 over 1? It's 1 over 2, or 1/2. So the slope of line 1 is negative 1/2 if the slope of line 2 was positive 2. Do you see that? That's the relationship between two lines that are perpendicular. What's the relationship between two lines that are parallel between their slopes? They're the same, right? They're equal to each other. So what's the relationship between two lines that are perpendicular? Well, the signs are different, and then you flip the slope, right? If it was 2 over 1, what's this one going to be? Negative 1 over 2. Okay? So let's just do a couple for practice, and this is pretty much, I think, let me take a look. Well, I got a little example to do, but as far as learning this stuff, let's do a couple quick examples. So what if I said the slope of one line was, I don't know, 2/3? Watch how I do it. I don't think they do this in the book, but I like to do this. What is the slope of a line that's perpendicular to this line going to be? You got it. Easy. Do you see that? Negative 3 over 2. Does that make sense? All right, let's do another one. What if I said, you need somebody? Okay. So what if I said the slope of a line was negative 1/4? What is the slope of a line that's perpendicular to that line going to be? It's going to be positive what? Not 1 over 4, 4 over 1. Or you could just say what? Just 4. That's fine. Okay? Everybody with me on that? Okay. What if I said the slope of a line was 0? What is the slope of a line perpendicular? Now, we talked about a line that has a slope of 0. What kind of a line has a slope of 0? Okay, it'd be a horizontal line, wouldn't it? Okay, so let's just draw a horizontal line. I'll just do it little right here. Okay. Now, what kind of line would be perpendicular to a horizontal line? Well, what kind of line? Vertical line. Okay, so that would be perpendicular to it, correct? If the first one was horizontal. So the first one has a slope of 0, so this has a slope of 0. What is the slope of this? What's the inverse? Can I take the opposite sign of 0? No, it doesn't have a sign. All right, so it's just 0. Now, I could put this over 1, or I could put it over anything, right? 0 over anything is 0, correct? How do I take the inverse of this? 1 over 0. But what is 1 over 0? Got a calculator? Is it nothing? Here, I got a calculator. Put it right here. So 1 divided by 0. Any guesses? What's 1 divided by 0? Is it 0? Is it 1? It's a good guess. It's 0? Why is it undefined? That's right. There it is. Look, the calculator says it's an error. It says you're trying to divide by 0, which means you can't divide by 0. All right? You're not allowed to divide by 0. And I could show you that, but I'm not going to right now because I got other things to talk about. But so this would be what? Undefined. Remember we talked about the vertical line and me hanging upside down almost to my bloody death? Do you remember that? Okay. So that's undefined. All right. So that makes sense though, doesn't it? All right. A horizontal line, if the slope is 0, perpendicular line to it's going to have an undefined slope because it's a vertical line. All right. There's really not many other choices with that. So let's do a regular example. Penny, if you need to go, you can go. Write a pass though. All right, so let's do the example they give you in the book. Let's get rid of all that. Flip my page over. So they are going to give you 4 points. They're not going to give you a graph. They're just going to give you the 4 points. So they call it points A, B, C, D. Actually, they give you 5 of them. So A is negative 3, 4. B is 3, 2. Then they're going to ask you a series of questions about these. And then C is 1, negative 4. D is negative 2, negative 3. And then point E is 0, 3. All right, so those are the points that they give you. So now let's, actually they only ask you 2 questions. Welcome. All right, so here is A. This is kind of what it might look like on a few questions on your homework, right? So they say tell, I didn't write it down, but you could write this down. Tell whether the 2 lines that they give you, I'll show you in a second, are parallel, perpendicular, or neither. All right? So here's what they're going to do. They're going to say line AB, and put a little line symbol over top of it, and line CD. So these are two lines. You can form a line with 2 points, can't you? Right? So it's all you need, or 2 points. You can make a line that goes in between them. So what we have to decide, we don't even have to graph this. That's the nice thing about it. You don't have to graph it to figure this out. You can just look at their slopes. All right? If you look at their slopes and they're equal to each other, then what are these lines? They are what to each other? What if the slopes were the same? What if they were equal to each other? They would be parallel to each other. The lines would be parallel to each other. Oh, by the way, I forgot to mention this. When I talk about the opposite sign and flipping it, what we say is the negative reciprocal. And I'll say that quite a bit. Forgot to mention it. So what's true about the slopes of a perpendicular line? Two perpendicular lines, their slopes are what? Negative reciprocals of each other. Everybody hear that? You know what that means, right? The negative, it doesn't mean that it's always negative. It just means you're taking the opposite sign. That's what it means, negative. Reciprocal, you just flip the fraction, okay? That's how you know if the lines are perpendicular. If neither one of those things are true, then you say what? Neither. What if the slope of one line was 2/3 and the slope of another line was 5/7? There's no relationship between them, is there? All right, so you would say neither. What if the slope of one line was 2/3, the slope of another line was -2/3? Are they? 2/3 and -2/3? They wouldn't be perpendicular because they're not reciprocals of each other. One's positive, one's negative, but does that alone make the lines perpendicular? No. All right, so both those things have to be true about being perpendicular. You got to have different signs, and then you got to flip the fraction on both of them, okay? All right, enough of that. Let's go back to this. So how in the world, without graphing it, do I tell if these lines are perpendicular, parallel, or neither? What do I try to find? Find the slopes. That's right. Find the slope of AB. So here's AB. So watch. I'm going to put slope, M for slope. I'm going to put a little tiny AB right there. It's the slope of AB. All right, so how do I find the slope of AB? Right, we just had a lesson on it. Right, we went over the homework earlier. So you subtract the y's. Let's go the first one minus the second one. So I'm going to go 4 minus 2. Then you subtract the x's. That's -3 minus 3. You work this out. 4 minus 2 is 2 over -6. Always reduce it. That's -1/3. Is that enough to tell if the slopes are, or if the lines are parallel or perpendicular or neither yet? No, I got to find the slope of the other one. Okay, I got to compare them both. So now what I'm going to do is find the slope of CD. Do the same kind of thing. CD, where's CD? It's these two right here. So let's subtract. I'll just go the first one minus the second one. I kind of like to do that a little bit better. So it's -4. It's not -3. It's minus what? -3. All right, so I did the y's, put them on top. Now I'm going to do the x's, the first one. 1 minus -2. All right, let's work this out. Minus minus is a plus. That's a -1. That's a plus. That's a 3. Check it out. I got -1/3 and I got -1/3. So what's true about these two lines? They are parallel. Now technically, you have 3 choices. You could just guess and have a 1/3 chance of getting it right. But the problem is, even if you get it right, if all you do is do that, do you think I'm going to give you credit for that? Absolutely not, okay? Because I have no idea how you got that. You might have just guessed, all right? And math is not about guessing, all right? It's about knowing what you're doing and showing me that you know what you're doing. So I need to see this. I need to see that those slopes are what they are, okay? Slope. M is slope. So this means the slope of AB. This means the slope of CD, all right? And that's what we're trying to find. That's what we care about. We care about the slopes. Let's do one more and we'll be finished. I will keep it up here since all our points are up here. So now we're going to take AE and compare it to BC. okay? So AE, that's that first one, and that's that second one over here. So I'm going to write this. You don't have to do this, but I like to. It's the slope of what? AE. Everybody got that? All right. So let's do A and E. Let's subtract the y's from each other. Remember, it's change in y, we're changing x. It's rise over run. So we do the y's on top and the x's on the bottom. So let's subtract the y's from each other. So that'd be 4 minus 3. See where I'm getting these numbers? This is the y of the first one. This is the y of the second one. All right, so 4 minus 3. Make sure you subtract the x's in the same order. So look at my x's. This is an x right here. This is an x right here. I subtract them. Negative 3 minus 0. Now I just do the work. 4 minus 3 is 1 over negative 3. There you go. All right, it's still. Now look, that's parallel to these two, isn't it? So 3 of the lines are parallel to each other. Yeah? But is it parallel to BC? Well, let's find out. Slope of BC. Getting the hang of doing a slope now? Yeah, pretty simple. Again, make sure you do the y's first, okay? Do the y's, put it on top. All right, so it's 2, what? Minus negative 4. And then do the x's now. 3 minus 1. That's 6 over 2. Reduce it, and that is positive 3. Now check it out. This is negative 1/3. This is positive 3. Is there a relationship between those two? Yes. Absolutely. They are what? Negative? Well, they are negative reciprocals of each other. That's the relationship between them. Okay, when I say what is a relationship, that's what I'm asking. Okay, now you can say it. Now what do I know about the two lines? Now they're perpendicular. That's right. So these are perpendicular. So you write that down. Perpendicular. That's technically your answer. Right? Because they're just asking you, are they parallel, are they perpendicular, or are they neither? So technically that's your answer, but you must show how you got to your answer. Everybody hearing that, right? Because from the homeworks, I don't know if everybody's hearing that. There's only a few. Most of you guys are doing a great job showing your work. Okay, I'm just talking to a few. I won't call you out. You know who you are. All right. So make sure that you show your work, even on a quiz or a test. All right. I have to see that you showed me how you got it. I got this girl in one of my classes. I'm not going to tell you who it is or what class it is or anything, but I can almost promise that she's sitting next to somebody that does pretty well, and I have a feeling that that girl that does well is maybe showing answers to the girl that's not doing so well, because she's getting answers that there's no way in the world that she could get those answers, and she just doesn't put any work. She just put the answer down. But I'm not falling for it, all right? I mark it wrong. So don't you be that person. It's not in this class, okay? So make sure that you show me how you got your answers, all right? Because I have no idea. Would you agree? I mean, you might be crazy smart and did it all in your head and wrote down the answer. I want to see what's going on inside your head, at least for the math problem, not for your whole life, okay? I want to see what's going on, and it's super important. I mean, there's memes on, well, I'm old, I just look at the Facebook, so, and I call it the Facebook, just to be silly. But there's memes that go around, I'm sure they're on Instagram and all that kind of stuff. And they make fun of math teachers about showing their work, and I've seen a bunch of them. People send them to me. Oh, Mr. Hamrick's so funny. You know, this teacher, he's a dork because he makes the kids show their work. But it's, you know, we get made fun of for that, but it's super important because I need to know that you know what you're doing, all right? Somebody that knows what they're doing, I don't think that's that funny, all right? I think it's important. But yeah, math teachers especially are always made fun of because we always make students show your work. In fact, I was going to order all these math posters at the beginning of the year, and then it just kind of fell through the cracks of the office, and I didn't get them. But one of them said something about, what do you guys say, low key or something like that? Don't you say low key all the time? And it said something about showing your work. You got to low key show your work. I forget exactly what it said, but I thought I'd put it up there. I thought you guys would laugh at it and that kind of thing. But it just shows you that you got to show your work. All right, you got to show your work. All right, enough of that. I'm done talking. you got the rest of the time. You got almost 20 minutes now to work on this homework. So let me give you the homework. It's 19 to 36. Excuse you.
We did 19 to 22 for
Okay, it's 23 to 36. How's that sound? Is that better? Yeah. So it's 23. Oh, is that right? To 36. I used to teach out of a curriculum where I gave 30 problems every single night. All right. So do you want me to do that? Don't complain about this then. All right. So this is section 3-4D. You can find the page number. Just go to 3-4. Look in the back. It's right after the last homework you did. And you're doing 23 to 36. Yes, sir.